This program is designed to calculate correlation coefficient and to do linear regression. It reads data, generates a scatter plot, calculates a person correlation coefficient, and does linear regression. So let's read the data. Let's look at the data. We have different genotypes, wild type and knockout, different treatments, tumor sizes before and after treatment. Now, if you want to look at the relationship between knockout and wild type tumors before treatment, we first have to define an object with the wild type, and we have to do the same with the knockout tumors. So it's the column genotype tumor, and it has to be equal either for wild type or knockout. Then we can do a scatter plot by using the function plot. So you can see here the graph. You can see it's done in purple, color purple. We have dots. It's by PCH, and we can give different labels. If we want now to plot the regression line, we simply have to say y is a function of x, so knockout sizes of wild type sizes, and we can do a regression line. Next, we can calculate the correlation coefficient between the two by simply using the function core. It's very close to 1. We can also perform a test. I close now the graph so you can see it better, and you can see it's of course significant, assuming a confidence level of 0.05, and we get here again the correlation coefficient. Now if we want to do actually linear regression, and we have the model that knockout tumors is a function of beta 0, beta 1 multiplied by the slope here by the wild type tumors sizes plus error, we have to use LM as a function that is for linear regression, and using summary we get already a summary of all the results. Keep in mind it's also first position here y in function of x. Let's look at it. You can see here as a result, we can see here we get the s-intercept and we get the slope of 0.99, which is a significant predictor. Now if we simply wanted to pull out one of these estimates here, we have to unlist, use the function unlist, and with the $sign here we can say what we want to pull out. So it's r squared. Let's look at this. Yes, we can see here 0.998, and you might remember that this r squared is actually the same as the correlation coefficient exponential to 2, and we calculate this and we can see, yes, we get the same number. Next, let's do a multiple regression. Let's test the model that the knockout tumors is a function of the wild type tumors and the treatment. So first we can say we do treatment, which is a categorical variable, as a factor. So we use here factor and we give the labels the right labels: placebo, treatment, and treatment A. And then we do exactly the same where we include now treatment in the model. We have the summary. You can see here the effect of treatment. As a reference we have placebo, so the increase or decrease in the slope if we go from placebo to treatment, or from placebo to treatment A or B. Keep in mind that this is very similar to the ANOVA, right? So it's again, we have here the F test for the wild type, as you can see here.